Alright, we've introduced sum and difference identities, right? These 4 formulas, although you can kind of capture them with these 2 phrases. And so now I'm going to show you how you'd use them to do a proof. So it says prove the identities below. Sine of x minus pi over 2 is equal to negative cosine of x. And the first thing to note is that this is a proof, and so we know this is a true statement. We have to show the steps that leads us from this side to this side. So I'm going to do my proof here, and I'm going to start with the side that looks arguably a little more complicated. And of course my goal is in the end to show that that's equal to negative cosine of x, and then I will be done. So it doesn't seem like there's much to do, except now that we have a difference identity, and this is the sign of a difference, we can use the formula. So I'm going to spit out the phrase, this equals sine cos same cosine, and now I'm going to put in the values x pi over 2, x pi over 2, and now I notice that I can evaluate cosine of pi over 2. That is, so this all equals sine of x times, well, what's the cosine of pi over 2? That's just 0 minus cosine of x, and the sine of pi over 2 we know is 1. And what do you know? This is going to work out as it should, because it's a proof, so everything is set up to work out. Sine of x times 0 is 0, so this equals 0. So this equals 0. Cosine of x times 1 is just cosine of x. And so I get my results. Okay, so I just all I did was write down the left-hand side and apply the formula, that's all. And then I evaluated, and I had faith it was going to work out because it's a proof, so it should. So what I'm going to do is give you an opportunity to try this one. I want you to try. So pause the video, try it, and I'm not going to talk through it. I'm just going to, do it out after you unpause, and then you can just see it. Alright, so hopefully you're back from trying it. There you go. So hopefully your steps were shown just like that. Alright, so let's try a couple more examples. So this example here says, write as the sine or cosine of one angle. So basically what this is asking is, this is like the sum or difference formula done out, and what we have to do is recover, like what was the initial trig function where we were, whether it was sine or cosine, and it should have been just one angle. So in other words, this is like the formula was applied, what was the original problem. Okay, sort of, you can think about it like that. So one thing I would notice first is that this is sine, cosine, cosine, sine. So if you look back, the one that alternates like that, sine, cosine, cosine, sine, is the sine. Right, the sine one. The cosine one is cos, cos, sine, sine for both. So it must be the sine of something. And then I'd say, Well, what are my two pieces? The 42 and the 17. So those must go here and here. And lastly, is it a plus or a minus here? Well, whether you use that phrase, if you pick that up, or you just go back and take a look, when there's a difference here, there's a minus there. When there's a minus there, there's a minus there. So that must mean that this is a minus. So we really were taking the sign, or this is another way to write the sign of 42 minus 17, which is 25 degrees. All right, and so that was all that was asked. We just needed to write the sine or cosine as one angle. All right, so let's deal with this one, tangent. We don't have any formula for tangent, although there is one. But I'm not going to teach you that formula because I find why memorize something you don't have to when there's a way around it. We don't know the tangent of 75, but maybe we can write 75 in a different way. So let's write it as the tangent of two angles we know the tangent of. So how about 30 degrees and 45? That looks good. Okay, but I don't have a formula for tangent. However, I do know that the sine of an angle divided by the cosine of an angle is the same as tangent. So I can use that here. So I can write this as the sine of 30 plus 45 degrees divided by the cosine of 30 plus 45 degrees. And now I have formulas for both the top and the bottom. So let's write out the top. The top is a sine one, so that's going to be sine, cosine, cosine. And the bottom is a cosine one. Cos, op, sine, sine, and then I go fill in. Again, this is how I like to fill in these formulas. Just if I have to memorize the formulas, that's how I do it, and I think it's helpful. Nice. Now we have to evaluate each piece. So again, this is something I'd expect you to do, and it may take you longer than it takes me, but you should still be able to do it. So sine of 30 is 1/2. Cosine of 45 is 1 over root 2. Plus cosine of 30 is root 3 over 2. Times sine of 45 is 1 over root 2. So there's my numerator. And then my denominator is cosine of 30 is root 3 over 2. Cosine of 45 is 1 over root 2. Sine of 30, minus. Right, minus. Sine of 30 is 1 over 2. And sine of 45 is 1 over 2. Alright, and so now I have let's just do with my numerator. It's look back to this piece here, right? We can eventually write it as one fraction, so I'm gonna trust your ability to do that, just so I don't go over too long. This is going to be 1 plus root 3 over 2 for the numerator, over 2 root 2, and then the denominator is root 3 minus 1 over 2 root 2. And now, first of all, I want you to notice that this denominator and this one match up, and that's not a coincidence. If that doesn't happen, you might have done something wrong, okay, if you're doing a problem like this. And what's nice about it is these divide, these denominators. And if you don't believe that, just think about this as dividing by a fraction multiplied by the reciprocal, and you would see that they divide. But what we're left with is, put the equal sign down here, what we're left with is 1 plus root 3 over root 3 minus 1. And there is an exact, so that's an exact answer to the tangent of 75 degrees. The appreciation for this should come in, or the appreciation for this type of problem is that, but there was a time when there was no calculators, and obviously mathematicians and engineers are interested in obviously exact values and how they can get them, and this formula allows us to get those values exactly.